All right, ladies and gentlemen, we are now on the very last video of the coronavirus pandemic. So, welcome to 7.2a, or 7.3a, sorry, 7.3a. And we're going to talk about these last different kinds of types of partial fraction questions. So, I stopped here at the end of the notes for 7.3 because this last particular question, example number 5, partakes on a style that we have saw in the particular one, which is going to be a type 3 question. Now, let's remind ourselves what the other two types basically were boiled down about. First type was if you had two unique types of solutions or answers that are real for the bottom, they come in the form of binomials, and those binomials would be set up separated with an A and a B over the top of them. Now, that particular type was type 1, where you have that scenario. Now, if you end up having repeaters, and you end up getting a repeating kind of concept where you get a multiple of the same binomial piece, and they repeat, then that repeater needs to be broken up into all of its forms, descending wise, of all the different kinds you can set up. So that was where we got A for the x, and B for one of the x minus 3s, and C for the x minus 3 squared, which is the other redundancy. Okay, now the type 3, if you read the example up here, it states that the type 3 is going to be based on the fact that it is a non-repeating, so we're dealing with a non-repeater again, very similar to type 1, but this time around we're going to be dealing with what's referred to as a quadratic prime factor. The key here is the word prime. Well, what this prime concept is really boiling down to is that you may end up running across a quadratic that cannot be factored into individual binomials, or, so this is a non-factorable, put that down, factorable, or you might actually run into one that specifically gives you, if you tried to solve it, non-real answers or imaginary answers if it was going to be talked about in its roots. Now, this one right here, you can definitely see that the non-factorable piece that we're focused on is going to be this quadratic right here. We start thinking about the x pattern on this one. There is no way we're going to be able to come up with any kinds of factors that are going to work in making multiples of 2 but add to the number 1. So this guy right here is definitely a prime quadratic factor. Now, how do we actually deal with this prime quadratic factor, and how do we set up the partial fractions? Now, again, I'm going to write the left-hand side, which is x squared plus 12x minus 20 is divided by x plus 3 and multiplied by x squared plus x plus 2. And what we're going to really get here is we're going to get really a mixture of both a type 1 and a type 3. So what we've got right here is this beginning part, this x plus 3, is very similar to what we've been discussing in type 1, where it's a distinctly unique integer type answer or binomial. So we would put x plus 3 on this one and just the letter A. Now, when we get to the second type that's listed right here, this one right here is what would be referred to as now a type 3. What do you do with a prime quadratic? Well, we definitely put the prime quadratic on the bottom, x squared plus x plus 2, but the top section is a little bit different than what we would be usually using. In the type 1s and types 2s, it was just a constant that goes up here. If it is a type 3 type question where you have a prime one, we use a linear function up here in the top in the form of bx plus c. Now, it could have happened here within the first one, and then it would be ax plus b, but this one just happens to be that we correspond and keep the next letters of the alphabet moving down the line. Okay, so this is the type of way that we would set up a type 3. Now I want to put like a scenario inside here. If I had something that was the same numerator as I had there before, and I had x plus 3 quantity squared, and then had the x squared plus x plus 2, this would be like a type 2 and a type 3 mixed together, where it has a repeater that goes with it, but then it also has the prime quadratic. So this would be something like x plus 3 with an A, a b over x plus 3 quantity squared plus a cx plus d over the x squared plus x plus 2. So we end up seeing each one of them as their own individual concept. If you've got the type 1s and 2s, we look to see are they distinct? Are they real? We just put A's. If they're repeaters, we get every distinct one below that and make the repeater run out. Or if it's a prime quadratic, it gets the cx plus d or ax plus b concept that goes with it. Now, in terms of the solving turns out to be exactly the same technique. You end up multiplying each side by the common denominator. I'm not even going to show it over here because it ultimately ends up canceling everything on the left side. And you end up with 8x squared plus 12x minus 20 is equal to, now you have to multiply it by this side, which is x plus 3 and x squared plus x plus 2, and you have to distribute it again on each one of the individual cases. Now, if I was distributing it on the a, the x plus 3's would cancel, and it'd be a times x squared plus x plus 2. And then if I was going to do the second kind, it would really end up being the bx plus c, that's the upper section, times the non-canceled part, which would be an x plus 3. Now, this does definitely deserve a little bit of simplification, and we're going to forget about the left side for just a little while and make some connections here. So ax squared plus ax plus 2x, 2a, plus, now over here with this bx plus c, it is very common, since this is already a binomial and the binomials might be left over, that we will have to FOIL these kind of things together to get the simplified version. So I'm seeing a bx squared with a 3bx, then the interior one would be a cx, and then finally plus 3c. And now we're just about organizing our thoughts together about which ones match. We've got squared terms like those two, and we get x squared is going to be multiplied by a plus b. And then I would go to another color, maybe for the x's. There's one there, and one there. And I'd be saying that this piece would be x times a plus 3b plus c. And then the final concept would be, is there any constant stuff? And the constants are these leftover amounts, which would be 2a plus 3c. Now, you've done a really good job of simplifying it. Now it's about equating to the left-hand side. Ax squared, or 8x squared plus 12x minus 20 is still left over on the left. And the squared term would give you a plus b is equal to 8. Then there would be a middle one of a plus 3b plus c is equal to 12. And then finally a 2a plus 3c is equal to negative 20. Now this is a great example of maybe when you might push ahead and use your calculator in an RREF way and write the augmented matrix that would be necessary for this. That would be a 1, 1, 0 with an augmented 8. I'm using 0 because there is no c in that first equation. Then a 1, 3, 1 with a 12, and a 2, 0, 3 with a negative 20. Now I'm making sure you put the 0 here in the middle of this one because there's no b value for the second or third equation. Now let's see if I can RREF this information. We'll go to second matrix and edit a 3 by 4 still. It's kind of nice that they've still been staying 3 by 4. 1, 1, 0, 8. 1, 3, 1, and 12. And 2, 0, 3, and finally negative 20. Now, if you ever get an RREF that doesn't look like it comes out relatively nice, go back. It's a good place to go back and check your dimensions and see whether or not you put it in correctly. I'm just going to show you that if you did end up doing that, I'm going to just paste, oops, we'll go to here. I'm going to quit that. I'm going to put negative 20 in that spot. Sorry, I was supposed to exit to the home screen. If I did matrix, just pasted the name on there, I could check to see if I entered it correctly, just looking at the matrix. And it looks like it's doing pretty good. So second matrix, math, I'm going to go again to RREF, which is at the bottom of that menu. second matrix and paste the matrix inside of row reduced echelon, and I'll get an answer of such. Now remember that you're looking for the identity matrix, and then whatever's left here is going to be the answers for it. So it says A is 2, B is 6, A is 2, B is 6, and finally C is, let me go back to that. I didn't see it. It was -8. Okay. Now let's just remember what those values mean in terms of their coefficients. You wrote the original one up there as A over x plus 3. So this is 2 over x plus 3 plus, that would be, wait a second, what did we get for B again? Why did I put B is equal to C? That makes no sense. B equals 6. That's better. B equals 6. That would be 6x minus 8 would be divided by x squared plus x plus 2. And that's the bottom that you set up in the original one. Now, let me say that not all the time do the answers come out to be nice, beautiful, wonderful integers. It could turn out that when you do your row reduced echelon, you may end up getting fractional values, like say you had A was equal to 1/6 or something like that once you do it. And you can get these 1/6 by also doing a math frac on your calculator. So if you're not sure what the fraction is, you can do a math fraction on the answer, and it'll change those into fractions if they were decimal equivalences. So it'll do that for you. If it turned out to be 1/6, then maybe you were sticking with that original statement that was 1/6 over x plus 3 is the way you would really like to write it. Your calculator or your Math Excel will not like this, and the technique that it'll want you to do is to really write the fraction as a separation between top and bottom, and you'd write this as 1 and 6 times x plus 3, and the 1/6 is written in that regard. That's the way you'd want to end up doing those kind of questions on a Math Excel deal. So if you run into a fractional answer that comes from your row reduced echelon, that's how you'll handle that particular scenario. Now, let's continue with a couple of these questions from part 2. This is the 7.3a still continued. And we're going to try a couple more of these questions just to make sure that you got the idea. Now, that one was a type 3. The really only difference now would be, what do you expect to see when you see a type 4? And there are only 4 different ones that you will end up seeing. Type 4 basically boils down that we're going to come back to this idea of a repeating prime quadratic, and we'll end up seeing how those particular ideas repeat. Now, you can see that this one is a non-factorable or prime quadratic, because if I still tried to factor it, it would end up generating your unreal answers or imaginary ones. So we're definitely thinking that it's a type 3. But the moment that it's got the square on it, it becomes a type 4. And it works in the same regard as what you would have done in a type 2, except that we're dealing with a type 3 repeater. And that would end up being ax plus b would be over x squared plus 1. And that's raised to the first power. And then a cx plus d over the x squared plus 1 quantity squared. And you deal with the repeater the same kind of way that you dealt with it in a type 2, except the fact that you're going to end up using the quadratic prime way of doing it with a linear piece up on the top. Now, again, you'll multiply by the common denominator on each side. 5x cubed minus 3x squared plus 7x minus 3 is what the left will be. And you'll multiply by x squared plus 1 quantity squared on each side and distribute it on each one of those. And you'll end up with an ax plus b will be multiplied by 1 extra x squared plus 1 that would be left over. And in the cx plus d case, the bottom and the multiplier would have canceled completely, and it just left you with cx plus d. So it's really not as bad as it looks, even though it does have A, B, and C and D answers that are associated with it. Now, a little distribution. We've got ax cubed for the inside plus bx squared plus ax 1ax will do for that one, and then plus b, or 1b, plus cx plus d. A little organization as well. We've still only got ax cubed. That takes care of him. Sometimes I cross these out as I find them. Plus bx squared. There's only one of those kind. The x's would be associated with a 1a plus c. And then the constants would be associated with 1b plus d. And all of those things are equivalent to everything that's on the other side from the left. And we can start to equate and make our equations. Now, being that there is A, B, C, and D, it could turn out that we could make a really large, ugly trinomial, but it actually turns out in this case that since the cubic is the A, we actually end up getting really easily, we get A is 5. And we even get B relatively easy, that B is -3, because those are the things that equate. We end up with an A plus C is going to equal 7. And finally, a b plus d is going to equal -3. Now, a lot of these are going to be relatively easy to come up with. If I plug in -3 for b and a d is supposed to make -3, that must mean that d is 0. And then last but not least, we might have a and c supposed to add to 7. Well, a is already 5. That means c's got to be 2. And those are our 4 answers that we're basically searching for. Now, if I'm writing those out, we would write something like 5x minus 3 would be divided by x squared plus 1, the single power of it, plus, and the c one would be 2x, and we wouldn't need to include the d because it's a 0 over x squared plus 1 quantity squared, and that would be your partial fraction decomposition. Now, if these equations turned out to be much more difficult and you ended up expanding relatively far, I would definitely say that doing an RREF would make a whole lot more sense. Okay, so be thoughtful there. You want to make sure that you're doing all the pieces that are going on. Okay, now the last question that's on your notes here, it says quadratic on top and bottom with a linear factor on the bottom, no repeat factors. So let's kind of think about what we're basically dealing with here. I see a combination of that's probably type 1. And this, since it's non-factorable, is a type 3, no repeaters. So the way you would set that kind of question up would be a over x minus 2, and bx plus c would be over x squared plus 2x plus 4. And you'd set it up that way to get yourself going. Okay, now I've got you the setup for it. I'm going to give you the opportunity to punch this guy out and see whether or not you can get the answers for it. And I'm going to pause the video and then come back with some magical information. All right, hopefully you ended up getting some equations that made a lot of sense here. We ended up in a times the quadratic and the bx plus c times x minus 2. Extended it all out, and then I combined some like terms and ended up writing 3 equations. Now, I'm not really in the mood to figure out those things by substitution or elimination, so I'm going to go right directly into a row reduced echelon, and that would be a 2, a -2. Notice that I took the -2b and kind of put it in the right spot. That can be helpful as well, too. 17. 4, a 0 for the b value that's not there, -2 and 14. This is the augmented piece. And I'd put this into my row reduced echelon. Now let's see if we can come up with an answer here for A, B, and C. Second matrix, it still happens to be 3 by 4. How wonderful is that? So no big deals. 1, 1, oops, that's 11, G. That's not 1, 1. 0, 3, 2, let's go -2. 1 and 17 with a 4, 0, -2, and last but not least a 14. Again, I'm going to check this matrix to see whether or not I plugged it in correctly. Just a quick little check for me to see if everything matches the way that it should, and I didn't make any input errors. So second matrix, let's go to math. We'll RREF this, row reduced echelon of matrix A. And we end up with three answers of 5, -2, and 3. So we've got A is 5, -2, and 3. I think that's what I said. I'll check again and see if I've got those same answers. Ooh, my memory's starting to be good. All right, now again, remember that if those answers were being plugged into your math Excel, that'd be something like 5 divided by x minus 2, and they may even use a minus in between here. You're going to have to read real carefully on where you put these in. I'm going to put a plus right near here and put -2x plus 3 over x squared. What was it? X squared plus 2x plus 4. And that would be correct. If you wanted to write this one with a subtraction, just be careful that that subtraction would change here, but it would also change this one. It's like you're stealing a negative out. So you could have written it with a subtraction between the two, but it'd be 2x minus 3 over x squared plus 2x plus 4. And that would be the same equivalence, okay? So no big issues there, just kind of like pay attention to how Math Excel is asking you to plug those pieces of information in, okay? The last little piece right here is about deciding whether or not you are completely capable of setting it up right. So if you have that as your composite, your put together, what would you write as your decomposition on the other side to get yourself going? Now I'm going to again pause the video at this point in time, and then I'll show you them all. You give them all a shot, and then you can see whether or not you can at least set them up right, because the rest of it beyond that point is just an algebraic process. And here you go, all the different types that you'd be basically looking at. And I'm just going to kind of highlight why they are the way they are. Definitely distinctive, real answers for those binomials. So just a simple type 1, A's and B's. Still a type 1, even though there are 3 of them, it doesn't matter how many there are. There could be 10. We could go all the way to A, B, C, D, E, F, G, whatever it is, all the way to F to figure that out. So that's still type 1. Type 1/2, the one in the front for the X is a type 1 because it's just a distinct answer of 0. The second one is 1, giving you a linear answer, or a real answer, but it's got a repeater on it, so that's why it's got the repeater sense for type 2. The fourth one down here, a type 1 for the front, that's why it's just A, but the second part is a non-factorable answer, or a non-factorable quadratic, so it deserves the bx plus c for that factor. And then the last one is a type 4 because it's a non-factorable quadratic, but it's got the repeater on it, which generates 2 of the repeater type answers for the prime quadratic style. All right. Now, ultimately, that should get you through, and you should be able to do the Math Excel for 7.3 and 7.3a. And do relatively well on there. Give those guys a try, and always reference back to these videos if you end up having a question. Now, since this is our last video for the end of the year, I wanted to leave you with something to kind of think about how how this particular time period has changed your way of thoughts. And ultimately, I have a small little video for you to watch because it kind of puts it all into perspective and hopefully makes us better people by the end of this particular deal. So ultimately, I'm going to give you a little video, and it's called The Great Realization, and I hope that somewhere along here we've realized something. Tell me the one about the rat scare, then I'll go to bed.
But my boy, you're growing weary, sleepy thoughts about your head.
Please, that one's my favorite. I promise just once more.
Okay, snuggle down, my boy, though I know you know full well. The story starts before then, in a world I once would dwell. It was a world of waste and wonder, of poverty and plenty, back before we understood why hindsight's 20/20. You see, the people came up with companies to trade across all lands, but they swelled and got much bigger than we ever could have planned. We'd always had our wants, but now it got so quick. You could have anything you dreamed of in a day, and with a click. We noticed families had stopped talking. That's not to say they never spoke, but the meaning must have melted, and the work-life balance broke, and the children's eyes grew squarer, and every toddler had a phone. They filtered out the imperfections, but amidst the noise, they felt alone. And every day the skies grew thicker, till you couldn't see the stars. So we flew in planes to find them, while down below we filled our cars. We'd drive around all day in circles. We'd forgotten how to run. We swapped the grass for tarmac, shrunk the parks till there were none. We filled the sea with plastic, because our waste was never capped, until each day when you went fishing you'd pull them out, already wrapped. And while we drank and smoked and gambled, our leaders taught us why. It's best to not upset the lobbies. More convenient to die. But then in 2020, a new virus came our way. The governments reacted and told us all to hide away. But while we all were hidden, amidst the fear and all the while, the people dusted off their instincts. They remembered how to smile. They started clapping to say thank you and calling up their mums. And while the car keys gathered dust, they would look forward to their runs. And with the skies less full of voyagers, the earth began to breathe, and the beaches bore new wildlife that scuttled off into the seas. Some people started dancing, some were singing, some were baking. We'd grown so used to bad news, but some good news was in the making. And so when we found the cure, and were allowed to go outside, we all preferred the world we found to the one we'd left behind. Old habits became extinct, and they made way for the new, and every simple act of kindness was now given its due.
But why did it take a virus to bring the people back together?
Well, sometimes you've got to get sick, my boy, before you start feeling better. Now lie down and dream of tomorrow, and all the things that we can do. And who knows, if you dream hard enough, maybe some of them will come true. We now call it the Great Realization. And yes, since then there have been many. But that's the story of how it started, and why hindsight's 2020.
Because if you look at
So a little message from me personally. I hope that you find that this time that we've been spending at home trying to stay safe and stay healthy really does allow you to find something a little bit more positive to look forward to when it all comes back. So take it for what it is and make it a better world the next time around.